Hello viewer and welcome to the e-learning classroom. So today we want to look at this setup. We have the glass block, that is the glass block here, and then we have the other components. We have the normal line NM, 2 pins, and the other 2 pins. We have distance D, the displacement of the emergent ray from the incident ray, and then we have this table, angle of this incidence, distance D in centimeters, sin I, sin squared I. Then we plot a graph of sin squared I against D, and then we calculate the slope, and then we'll be finding D when the angle of incidence is 45 degrees. So I want us to use a shortcut to be able to do that. So let's first mount the plain papers. On the softboard. Let's start by mounting plain papers on the softboard. So we have this paper and this other paper here. These are 2 plain papers. Then we trace the glass block. Somewhere in the middle, we trace the outline of the glass block. We have to hold it firmly for us to be able to trace its outline. So we have traced the outline, and then from there we remove the glass block, and then we want to mark a normal line NM. So we first mark a point. Close to the end. Let's say that's our point. We measure an angle 90 degrees. So we have that. So from there now, we'll join these points. So we join these 2 points now with a straight line to draw the normal NM or MN. So that is our normal N there and M down here. That is our normal now. So from there what we do, I want us first to measure these angles 20, 30 up to 70, so that when we replace the glass block we just be able to measure, to replace the other pins immediately. So let's replace back. Let's measure those angles first. The baseline must be in line with the normal. So we are measuring angle 20 to angle 70. So 20, 30, 40, 50, 60, 70. Those are the angles. Remember viewers, I told you now I want us to do it within a short time. So we are using a shortcut. So initially we normally do it each angle individually, but we are going to do them together now. So let me start with drawing all the angles. Let me draw all the angles. So those are the angles, viewers. Those are all the angles. So from there, what I'm going to do now, I'll replace back the glass block, and then we'll start with we'll draw all the angles together. So I'll replace back the glass block first. You have to check all the sides. You have to confirm all the sides, viewers. So I replace back the glass block, and then what I do, let me start with the first angle 20. The pin there. And there. Then I look for those two pins through the other side. So those two pins are there with the search pin. Let me do the same for the other angle because I want to do it all at once. Told you want to use a shortcut for the sake of time. So let me search now for the angle 30. For the angle 30, there we have the angle 30. I search for the other two pins. So we have the pins there for the angle 30. Let me go to the angle 40. Remember, you can only do this when you have enough number of pins. That is the angle 40. So let me search for the other angle 40. You have the first pin, and the second pin for the angle 40. I go now to the angle 50. The angle 50. That is for the angle 50. Then the angle 60. We have the angle 60. We have the angle 60. Then lastly, the angle 70. Lastly, now as we finalize the angle 70. Let me search that angle. So I have now the angle 70. Viewers, now I've measured all the angles. So I want now to draw to complete these lines. I want to complete these lines now so that we can be able now to proceed with the rest of the graph. So I can first remove the glass block and these two pins. So what I do now, I'll be removing pairs of two pins as I complete that line. So I'll be removing pins in pairs as I complete the line. So let me first start with these two pins. So I draw that line, I complete that line first. Then I can remove these other two pins. I do the same. I can remove the other 2 pins again and do the same. The other 2 sets of pins and do the same. Remember, you can only do this when you are an expert in that field, because normally you are given only 4 pins, so you will do each set individually. Those 2 pins, these other 2 pins again, you can see the pattern is appearing already. These 2 pins, then lastly, the last 2 sets of pins, the last pair of pins, so I have all the pins now drawn. So from there, what I do now, let me make some holes and then I complete those lines. Let me make some holes here. Then I complete those lines. I complete these lines now. Let me start with this one. The next 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 one, which is the last one. So viewers, this is what we have. This is what we have, viewers. Now we are remaining with only drawing the line from the point of that, from the point of 3 centimeters here. So I'll measure now these 3 centimeters, and then I draw that line, horizontal line, which will now use to measure the distances and fill the table. So let me measure that distance now, 3 centimeters. centimeters is there. Can measure another one here so that I join those 2 points. So we have 3 centimeters. I measured twice so that I join the 2 points to avoid any error while drawing that point. So that is the line PQ now. This is the point P, and this is the point Q. So we have the line PQ. So we are now taught to measure those distances and now to fill the table. To measure those distances and fill the table, again I can measure all of them at once as I record the table. So I'll just place it there. I'll just be reading each distance individually and recording because they are all here. So the first one is 2.5 centimeters. The second one is 4.1. The third 5.7. 5.7. The next one for 50. 7.6. The next one 9.5. 9.5. Then last one for 70. This one is 13.7. 13.7. Those are the values we have. Once we measure all of them, those are now the values we have. This is A, B, C, and D. And that is now the full setup. So we can now fill the table for the sign of angles of incidence. So we have sine 20, that is 0.3420. Sine 30, 0.500. Sine 40, 0.6428. You are filling in 4 significant figures for the work of calculator. Sine 50, 0.7660. Sine 60, 0.8660. Then lastly, sine 70, 0.9397. Those are the values for sine. So viewers, we can find now the square, sine squared. So that means we start with 0.3420 squared. That gives us 0.1170. Then we have 0.5 squared. That is 0.25. 0.6428 squared. That is 0.41. 0.4132. Then we have 0.766 squared. 0.5868. 0.866 squared. 0.74. Actually it is 7500. 7500. 0.9397 squared. 0.88. 0.8830. So we are now plotting a graph of sine squared against d. A graph of sine squared against d. So what we do, we start by drawing the axis. So we start by drawing the two axes. So we have the first axis here. And then we have the second axis here. We can put arrows. Also arrow here. So since we are plotting a graph of d, sine squared I against d, so this side we call it sine squared I. This one we call it d, let's say in centimeters. You label the quantity and the unit, d in centimeters. From there, for d we have up to 13.7. Let's see how many squares we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we'll work with each square to represent 1. That means 2 squares. I'll write 2, 4, 6, 8, 10, 12, 14, 16. So we now look at the sine squared axis. So the largest value is 0.9. The largest value is 0.9. So that means 2 squares, 0.1. So 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1.0. So we are done with the scale now. We are done with the scale. So from there now, what we do, let's see, we need now to make these values in a plottable format, because we are working with D against so let's form a small table which can help us to plot. These are 1, 2, 3, 4, 5, 6 values. So we have, let's say, 1 there, 1, 2, 3, 1, 2, 3. Let's call this sin squared I. Let's call this D. So the accuracy of sin squared axis, this axis we are working with 10 squares to represent 0.1. That means each square is 0.01. Then for D, 10 squares is 2, so each square is 0.2 centimeters. So we can now divide these values to find the plottable format. Let's start with the D. 2.5 divided by 0.2. These are 12.5 squares or divisions. 4.1 divided by 0.2, 20.5. 5.7 divided by 0.2, 28.5. 7.6 divided by 0.2, 38. 9.5 divided by 0.2, 47.5. Then we have 13.7 divided by 0.2, 68.5. These are the number of small squares or divisions. Let's go to sin squared. 0.117 divided by 0.01. These are 11.7 squares. The other one will be 25 squares. The other one will be 41.3 squares. 58.7, 75 squares, then 88.3 squares. So this is now what we are going to plot. So we can place it there. So we start with the D. 12.5 squares. These are 10. 12.5 is here. We go up 11.7. So 10, 11.7, 12.5. There. That is the first value. We go to the second value. 20.5. 20 is here, so 20.5 is here. We rise up 25. 10, 20, 25. There. 28.5. 28.5 is here. Then we rise up 41. 10, 20, 30, 40, 41. So the value is there. Then we go 38, 10, 20, 30, 38. We rise up 58.7. 38 is here, we rise up 58. 10, 20, 30, 40, 50, 58, that is 58.7, somewhere there, 58.7. Then we have 47.5, 10, 20, 30, 40, 47.5 is there, we rise up 75, 10, 20, 30, 40, 50, 60, 70, 75 is here, then that is 47.5 here. We have there. Then we proceed. The last value we have 68.5, 10, 20, 30, 40, 50, 60, 68 is here. Then we rise up 88, 10, 20, 30, 40, 50, 60, 70, 80, 88 is here, then 68.5, let me confirm again, 68.5, 10, 20, 30, 40, 50, 60, 68.5 is there, then we rise up 88, 10, 20, 30, 40, 50, 60, 70, 80, 88 here, so 88.3. So that mark is there. Those are now the values we have. So from there, viewers, now we complete the line of best fit. So we have the line of best fit now. So that means we join these points. To obtain a line of best fit. So that is the graph we have obtained. That is the graph or the line of best fit. Then from this line, we are now to determine the slope. So we pick 2 readable points to obtain the slope. 2 readable points to obtain the slope. So we can pick this point. The other readable point. Can pick this point. So let's read this point. These are 10. These are 10, 15, 16. So we have 16 times 0.2, that is 3.2. Then on the upper side we have 10, 15, 17. 17 times 0.01, that is 0.17. Then on this other side, these are 10, 20, 30, 40, 50, 51. 51 times 0.2, that is 10.2. Then on the upper side we have 10, 20, 30, 40, 50, 60, 70, 80, 81. So 81 times 0.01, that is 0.81. We are multiplying by the accuracy. So we have those values. So we are going to determine the slope of the graph. So we know slope will be given by changing sin² I divided by changing d. And this means 0.81 minus 0.17 divided by 10.2 minus 3.2. This gives us what? Let's see the numerator into bracket 0.81 minus 0.17 divided by 10.2 minus 3.2. This gives us 0.0914. This one will be per centimeter. Per centimeter, because we have centimeters in the denominator. Then find d when angle of incidence is 45. When angle of incidence is 45. Remember, the graph we have here is a graph of sin² I against d. That means we first get sin² of 45. So we have sin 45. So sin 45 degrees is 0.7071. Then sin² 45. So we square that 0.7071 squared. That gives us 0.500. So in that case now, we look when sin² is 0.5, what is the value of d? So when this one is 0.5, that means you have this point here. Then we drop with it here, down here. We drop with it down there. So, and that means now what we have, these are 10, 20, 30, 34. So we have 34 times 0.2, which is 6.8. So D is 6.8 centimeters. So viewers, that is how we solve that practical, and that marks the end of that comprehensive practical. I wish you all the best.